Statistical decision theory involves making decisions in the midst of uncertainty, and that uncertainty is present in the fact that we don't know the underlying parameters associated with our data, with the distributions involved. And so those parameters, as usual, are denoted with a theta. That unknown value is referred to as the state of nature. So it's the unknown parameter. And so you'll notice there that there's little theta and big theta. Big theta is the parameter space. So if we're talking about perhaps some data following an exponential distribution, then theta would have to be a positive real number. And so in that case, big theta would be the set of positive real numbers, and little theta would represent the specific real number, that applies to the distribution. And so therein lies the source of the uncertainty that was referred to earlier. And so the essence of decision theory is to make decisions in light of this uncertainty, but given the statistical knowledge that we have. Now, we do this sort of in classical statistics, but in classical statistics, we usually just focus on the sample. Now we're going to focus on the sample and then some other things, as we'll see later. So our first example that we have involves a drug company, and there are two parts to this parameter theta. So we've got an element of R2. Theta 1 is the proportion of individuals for which this new drug would be effective, and then theta 2 is the proportion of the market that the drug would capture. In a classic statistics fashion, we would consider a sample to estimate these parameters. But in this example, we're sort of ahead of the game, right? There is no data to consider because nobody's taken this drug, it's not to market, so we don't actually have data to look at. And so this drug company needs to make a decision beforehand. So, what is to be done here? Well, we could look at what's called prior information, and that is a big part of Bayesian statistics, which kind of goes hand in hand with statistical decision theory, and so which is a big part of this course as well. And we will look more into how that all plays out as the course progresses. So we have these parameters, and we have to make a decision. And so the decision that we make about this uncertainty is what we'll call an action. Now, let me also back up and mention that even though these parameters, in example 1, these, for example, the two proportions, they are constant, but in Bayesian statistics, we treat the parameters as random as well. So not only will the x's, the data, be random, also the parameters, the theta, will also be random. And so we will look at it from that viewpoint, and there'll be more about that as we move on. And so again, the decision that we make, and when I say decision, I mean the value of the parameter that we go with is what we're going to call an action. And you can see the definition there. An action will be denoted by lowercase a, and then this fancy A, the script A, if you will be the action space. And so a simple example there, example 2, is, when you conduct a hypothesis test, there are only two decisions, right? You either reject or you fail to reject the null hypothesis. Alternatively, we might be wanting to give a point estimate of some unknown, like binomial proportion, and of course that's another classical statistical problem that's usually done based on data. But in that case, the action space, right, the set of values from which or theta could come would be the closed interval from 0 to 1, as you see there.